welcome to my video lecture on utilization of electrical power. In today's topic, we will highlight about mechanics of train movement. Myself, Poonam Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra, Degree Engineering College. In our previous lecture, we have done several numericals, theory related to steel train power, trapezoidal power related to speed and train movement. Here we will again go further about train movement and the mechanics behind it and what are the mathematical aspects or what are the effects when train is moving with its motion that we can see through this lecture. And here we will highlight some mechanics of suppose gravity, earth gravity, or the weight of train when it is fixed carriage or when it is train of carrying normal local trains where huge amount of weight needs to carry and what are the effects are there when the train is movement with that we will see here. So first we will start with mechanics of train movement. Essential driving mechanism of an electric locomotive is shown in this figure. The armature of the driving motor has a pinion of diameter d' attached to it. The tractive effort at the edge of pinion is transferred to driving the wheel by means of a gear wheel. So see here, this is transmission of tractive effort. Here this is the gear wheel, this one. Next this is road wheel. And here the motor is connected. So this is the armature of the tractive motor. And this is the pinion. And the diameter of the pinion is given, that is d'. And the whole diameter of the road wheel is capital D and the diameter of the gear wheel is small d. And the force of F' is given by the gear wheel and the force of F is given by road wheel. That means when a train wheel is moving, definitely a huge amount of friction is happening, and with help of the tractive motor like DC series motor, with help of drives, the train is moving, and at the time it will offer some frictions and a huge amount of force is created, and the armature of the motor is connected with the pinion of the motor is connected with the gear wheel, and it will create the force F' in the gear wheel, and another force is created in the road wheel. That means actually the force is given by the motor in the gear wheel, and from using that gear wheel the force is coming to the road wheel part as for mechanics. Okay. Now next, the driving motor exerts the torque T in Newton meter. Tractive effort of edge of pinion is given by equation T equals to F' D' by 2. Here, this is the tractive effort at the edge of pinion is given by this equation, that means this one, and F' is the force 2T divided by D'. Therefore, the tractive effort transferred to the driving wheel is capital F equals to epsilon F' d by d theta plus 2T d by d, and ultimately we are getting theta capital T to delta by capital D. To gamma by capital D. Where D is the diameter of the gear wheel in meters Capital D is the diameter of driving wheel in meters. Epsilon is the efficiency of the transmission. Gamma is the gear of ratio and equals to D by D, which we have already seen in our previous diagram. These things we have highlighted here. The maximum frictional force between driving wheel and track is mu omega. That is, here it is written mu omega, where omega mu is the coefficient of adhesion between the driving wheel and the track, and W is the weight of the frame on driving axles, called adhesive weight. This is very important term, adhesive weight. Slipping will not take place unless the tractive effort capital F is greater than mu into W. For motion of trains without the slipping, tractive effort F should be less than or at most equal to mu W, but at no case greater than mu W. So here the main important thing is mu is the coefficient of adhesion between driving wheel and track. W is the weight of the train on the driving axles, which is called adhesive weight, and the slipping will not take place unless the tractive effort capital F is greater than mu W. Okay. Now the magnitude of tractive effort that can be employed for propulsion therefore depends upon weight coming over the driving wheels and the coefficient of adhesion between the driving wheel and track. The coefficient of adhesion is defined as mu equals to the maximum tractive effort that can be applied without help. So ultimately the coefficient of adhesion becomes mu equals to maximum tractive effort that can be applied without slipping of wheels, and adhesive divided by adhesive weight, which is weight on the driving wheels. This is very much important part here. Next one, the tractive effort for propulsion of train. The effective force necessary to propel the train at wheels of locomotive is called tractive effort. It is tangential the driving wheels and measured in newtons. The total tractive effort required to run a train on track equals to tractive effort required for linear and angular acceleration plus tractive effort to overcome the effect of gravity plus tractive effort to overcome the train resistance. That means the total tractive effort required to run a train on track is equals to tractive effort required to run for linear and angular acceleration plus tractive effort to overcome the effect of gravity plus the tractive effort to overcome the train resistance. So these are the main components for tractive effort of propulsion of train. That means when a train is running with its wheel, some necessary tractive effort is required, and those tractive efforts are based on these three components. One for linear and angular acceleration, second one is overcome the effect of gravity, and third one the tractive effort to overcome the train resistance. Now several other factors are also there. In this lecture I will concentrate only first part of the tractive effort effect, and remaining part we will continue in our next lecture. So the first part of effect of tractive force, that is the tractive effort for acceleration. So tractive effort for acceleration. According to the laws of dynamics of force is required to accelerate the motion of the body and is given by force equals to mass into acceleration. That is well known to us. Consider a train weight W tons being accelerated at alpha kilometer per second. The weight of the train is 1000 W kgf. Mass of the train m equals to 1000 W kg, and acceleration is alpha kilometer per second. Then it becomes alpha equals to 1000 divided by 3600 meter per second square. That means ultimately the acceleration is 0.2778 alpha meter per second square. And the tractive effort required for linear acceleration, that is if a equals to m into alpha, that is equals to 1000 into 0.2778 alpha. So ultimately it will be 277.8 W alpha newtons. Okay. So this is the force of acceleration for linear acceleration. With linear acceleration of the train, the rotating part of the train such as wheels and motors also accelerated in an angular direction. That means a train is not suffering only for linear acceleration, it also has some angular acceleration also. And therefore the tractive effort required is equal to the arithmetic sum of tractive effort required to have the angular acceleration of rotating parts and the tractive effort required to have linear acceleration. The tractive effort required to have angular acceleration depends upon the individual weight, radius of orientation, etc. of the rotating parts requiring the angular acceleration. That means the angular acceleration is dependent on the weight and the radius of orientation, etc. of the rotating part. Hence, the equivalent or acceleration weight of the train is taken as Wb, which is higher than the dead weight W required linear acceleration to consider the tractive effort for the angular acceleration. In practice, Wa is the higher than W by 8 to 15%, and the normal value lies between 10 to 12%. Hence, the tractive effort required for acceleration equals to Fa equals to 277.8 We alpha newton. Okay. So up to this is much for today's lecture. In our next lecture, we will continue about this tractive effort. Then some other effects are also there. Tractive efforts like tractive efforts for gravity, tractive efforts for train weight. Those things we will highlight in our next lecture, and we will also do some numerical related to tractive effort to understand what are the actual effects occurs when the train is on movement. So thank you for listening my lecture.